Alright, Sierra and I have decided to transform the road distance problem. And I have drawn up in Geometry Sketchpad the diagram. So let's take a look at it. We have our three streets, our three parallel streets, Wilmington, Beach, and Ash Grove. And then we have our two transversal streets, Magnolia and Kendall. And we can look at this diagram and the information that we're given and see that it's a very boring diagram. And we can easily imagine that a high school student with a short attention span will not be interested in studying this diagram and seeing what's going on. So to take this problem and make it into a real-life applicable situation that can satisfy the interests of your average high school student, we need to find a real-life scenario that fits this diagram. And before we can do that, we need to examine first our information that we're given. And what we know is that this distance along Magnolia from Wilmington to Ash Grove is 660 feet. The corresponding distance along Kendall from Wilmington to Ash Grove is 820 feet. And from Beach to Ash Grove along Magnolia is 280 feet. And the question is, what is the corresponding distance here along Kendall from Beach to Ash Grove? So in your average, or in your typical geometry classroom, students will have learned how to do proportions, and they may recognize right off the bat, okay, I'll just set up a proportion, cross multiply, and voila, I have X. Pretty straightforward plug and chug kind of problem. But that's not the direction we want to take. So what we've done is we've found in Google Maps is a real life situation that depicts the scenario given to us in the problem. So we'll open up Google Maps and we can see we have a few roadways that reflect the scenario. We have our three parallel streets, East 14th, 15th, and 16th Avenue. And we have our two transversal roadways, Kenton Street and Greenwood Alley. And we can compare these side by side and make sure that what we have is not only accurate, but it's relevant to the students. And we purposely picked out these streets because they would be relevant to students. The roadways that we found are fairly popular roadways here in Bowling Green. I'm just going to shimmy this over. And if we look, we can see we have our three parallel streets and we have our two transversal streets. And now our next step will be to measure some of these distances that are provided. And we can do that using the distance measurement tool that's found on Google Maps. And I opened that up using this little ruler here in the corner. I click it and we get the distance measurement tool. And this actual activity can be done in a computer lab in a high school room, and it incorporates technology, which is always a good thing to do in the classroom because you always find students clicking away on cell phones and stuff. So it's a good way to get them involved and engaged in an activity or a lesson. Now, to measure these distances, once you have the distance measurement tool open, all you need to do is you'll come here to your map and you're just going to click, and it'll place this green arrow, and we'll drag this first arrow to the middle of our intersection and drop it. And then to measure the whole distance here, we'll click again in the opposite intersection, and we have our whole distance of Kenton Street from East 16th to East 14th as 282.5 meters. And if we want that in English, we can easily convert it to feet. And students, once they've done this, they'll write this distance down, and you click reset. And again, we want to measure the whole distance of Greenwood Alley from East 16th to East 14th because, as we can see in our problem, we have the whole distance of Kendall, or from Wilmington to Ash Grove along Kendall and Magnolia, which are these two transversal lengths. So we'll come back to our problem, click and place our green arrow where we want it, and we'll go to our opposite intersection, and we can see that we have 282.1 meters, or in English we have 925.6 feet. And again, students write this down. Now for our last distance that we need to measure is Beach to Ash Grove along Magnolia. Now, in our problem, Greenwood Alley represents Magnolia and Kenton Street represents Kendall. So the trick is to figure out where we want Beach and Ash Grove to be. And to do that, I'm gonna open this up so we can look at the problem. A little better clarity here. Click reset. And it doesn't particularly matter which street we define to be which. We know that Greenwood Alley is Magnolia. So it's up to students to pick which segment, either this segment between East 16th and East 15th, or the segment between East 15th and East 14th. Students in a classroom can pick, and it's okay to let them pick either one, because if some students pick this first segment and others pick the second, then once the activity has completed and they found the distances, then they can compare and cross-check and make sure that they have the right answers. So we're just going to let Beach and Ash Grove be these two streets, and then we'll come again to our measurement tool. Oh, don't want to go to Miller's AAA. So put our green arrow, and then place our red arrow as just the segment. And here we can see students will have measured in English 490.7 feet, or in metric 149.5 meters. And again, they'll write this down. And at this point, they have gathered all the information on their own in a real life scenario. They realize that they have the three parallel streets, and they have the two transversal streets, and they've measured them on their own. And now the next part of the activity consists of them physically, experimentally measuring this distance along Kenton Street. And once they physically measured that, after that, we will come back and mathematically determine the distance. And we're going to look at the proportion compared to the physical value. And we're going to see how accurate we've measured and how accurate Google Maps is even.